One dangerous thing about production incidents is that security controls usually break during pressure situations. Imagine you are working in a production environment and deployments start failing. Everyone wants logs, pressure increases, and teams start enabling emergency debugging. Today, I'll show you a very realistic DevSecOps incident where troubleshooting a production deployment accidentally created a security problem. If you work with CI/CD pipelines or production deployments, this is something you absolutely need to understand. Now, I'm going to create a file Python, very simple once again, as we did in our previous episodes. I'm going to write some simple Flask application code. The focus is not application development here, it's around operational pressure around deployments. Followed by, I'm going to add requirements.txt file real quick. Requirements.txt file, and in this file I'm going to add Flask. Followed by, we are going to create a Docker file. I mean, it's the exact same setup which we had in our previous episodes. If you are following from episode 1, definitely you will relate to this episode as well. So I'm going to go back to my Docker file. This is, let's say, a production grade Docker file. I'm going to copy this exact file and write it down here. As I said, the goal is completely deployment perspective. That's the reason I'm not going to explain in detail about this particular Docker file as well, because we already did that in previous episodes. First, I'm going to, right now I'm in this particular directory. I'm going to build this Docker image real quick. So I'm going to say Docker build production debug demo version 1. Press enter. So we have built the image successfully. I did not come across any kind of problem so far, correct? Followed by, what exactly we are going to do. Here in the workflows.yaml file, I'm going to create a file named deploy.yaml. In this file, I'm going to write some workflow.yaml file. If you see, again, it's very simple. Production deploy followed by pushing it on main branch. Then we are trying to run on Ubuntu latest. Working directory would be episode 4 production debug incident. Environment would be prod, and this pipeline has API token from GitHub secrets. I'm going to show you that as well. Followed by, we are trying to check out, build the Docker image, and trying to deploy the application. Very simple. I'm going to save this and let's try to run this. Git commit -m add episode 4 folder push. Now I am in the GitHub UI. I'm going to click on this pending and I see production deploy pipeline is running. By the time it runs, let me jump back to the settings, and in the settings we have environments. So I did create this environment prod with a secret. So I'm going to click this. You can see API token. It was created some time ago. Just for this demo purpose, I created this token. Followed by, let's jump back real quick. I'm going to look at the pipeline and the pipeline is failing. Setup job, checkout step, building the Docker image. The pipeline is failing and I do not see any kind of more information of what exactly is going on with the pipeline. Now imagine this in real production environment. Releases get blocked, teams are waiting, you get messages everywhere from emails, from different channels. everyone is asking you what's happening. Now we are trying to simulate this particular failure. Instead of stopping the entire pipeline immediately, we are going to continue the debugging step. So previously we had only deploy application and we were trying to run this. Now I try to add an ID with a deploy continue on error equal to true. That means if the pipeline fails, it will try to continue with the next steps. After this step, emergency debugging starts automatically. If steps deploy.outcome equal to failure, if this is failing, we are trying to define this particular step here. Run echo deployment fail and try to write it to the debug.log. Then once again echo starting emergency debugging. We are trying to add this to the debug.log file. So after this, we are trying to run curl-v command with authorization token and the URL, followed by we are trying to write everything into this particular debug.log file. This is very common. Engineers enable curl-v verbose logging during incidents all the time, so that this particular command will help you with request details, headers, authentication information. That means basically everything. At this particular stage, nobody is thinking about security anymore. They want production fixed as soon as possible because of pressure. Now, all the debugging which we are trying to do is being written to this particular debug.log file. And this is where incidents quietly begin. Because after this particular step, we are trying to upload the same debug.log as an artifact. If you see here, upload debug logs, if always, with name debug.logs, path would be in this particular location if no file found error. Now, according to this particular step, the debug.logs are being uploaded as artifacts. Why are we uploading it? So that multiple engineers can inspect that quickly and resolve the production issue as soon as possible. This is completely normal operational behavior. At this particular point, deployment issue is already understood. Teams relax, incidents look under control. Now, let's try to add this and try to run the pipeline real quick. Git add git commit -m followed by update pipeline with debugging step. Git push. Production deploy was successful. I'm going to open this real quick and I can see the green pipeline now because Docker build was successful, deploy application was successful. It got an error. We enabled emergency debugging here. So I can see debug.log here, followed by uploaded debug logs. Also, if you see, I can see artifact download URL. I can click on this link. It tried to download this for me. I'm going to quickly open this particular log file. Now, this is our log file. If you see, clearly everything is written in this particular log file. And if you scroll down, now look at this authorization, bearer, and the password token. Production API token is now stored inside CI/CD artifact. This is an artifact. Now, anyone with this particular artifact access can easily retrieve deployment credentials, production API access, internal system access, depending upon what this particular token can control. This was not malware, not sophisticated hacking, just operational pressure. And if this particular token also had Kubernetes permissions like we saw in episode 3, this incident becomes much worse. Now, let's look at the pipeline once again. Instead of writing curl -v, I am going to replace this with silent -fail. And sensitive logs should never be uploaded blindly as artifacts like we did here. Majority of the teams try to do that. Mature production systems usually combine restricted artifact access, secret masking, short-lived credentials. Now I'm going to add this real quick. Commit -m update pipeline git push. Just to show you the difference between curl -v versus silent fail. The pipeline is running and I can see it is already success. Let's look at the debug.log. I'm going to open this. Now look at this. We have very less information in this particular log file, and also the secrets are not being exposed clearly. This is how you need to have controlled behavior. Most production environments are not compromised by one giant mistake. They are compromised by many small shortcuts during stressful situations like we discussed today. Healthy systems can still be insecure systems. Thank you for watching and see you in the next video.